In question 1a, we have to express x squared minus 8x plus 11 in the form x plus b whole squared plus q. Now, to convert this in the form, we can use a comparison method. So the original expression was x squared minus 8x plus 11. And if we expand the expression x plus p whole squared, that will become x squared plus 2px plus p squared and plus q. Now, comparing the coefficients, the coefficient of x on the left-hand side is minus 8, and on the right-hand side, it's 2p. So we can say that 2p equals to minus 8. P will be equals to minus 8 divided by 2, which is minus 4. Now, comparing the coefficients, the constant on the left-hand side is 11, and then the constant on the right-hand side will be p squared plus q. We already have the value of p, which is minus 4 whole squared plus q equals to 11. So q will be is equals to 11 minus 16. Minus 4 whole squared will be a plus 16. So when it comes on the right hand side, it will become a minus 16. The value of q will be minus 5. We can finally write our answer as x plus p. So p is minus 4. So this will be x minus 4 whole squared, and q is minus 5. So this will be the values of p and q, minus 4 and minus 5. In part B, we have to find the exact solution of the equation x squared minus 8x plus 11. Now we can bring the one on the left-hand side and apply the quadratic formula, or we can just simply use the expression that we converted to in the first part. So we converted x squared minus 8x plus 11 to x minus 4 whole squared plus minus 5, and we'll put it equals to 1. Taking 5 on the right-hand side, this will become x minus 4 whole squared equals to positive 6. Now to get rid of the whole square, we'll square root both the sides. So this will become x minus 4 is equal to square root of 6. Now square root of 6 can be a plus or a minus. So we'll write it as x minus 4 equals to square root of 6, and x minus 4 is equals to negative square root of 6. So the final answer will be 4 plus square root of 6, and x is equals to 4 minus square root of 6. In question 2, the 13th term of an arithmetic progression is 12, and the sum of the first 30 terms is minus 15. We have to find the first 50 terms of the progression. So as the 13th term is 12, the nth term formula for an AP is A plus n minus 1 into D. So the 13th term is 12. We'll write it as 12 is equals to A plus 13 minus 1 multiplied by D. This will become A plus 12D equals to 12. And the sum of the first 30 terms is minus 15. So the sum of n terms of an AP is given by n upon 2 into 2a plus n minus 1 into d. As the sum is minus 15, so we'll write it as minus 15 is equals to the number of terms is 30. So this will be 30 upon 2 into 2a plus 30 minus 1 multiplied by d. Cross multiplying, we'll get minus 30 is equals to 30 bracket 2a plus 29d. 30 divided minus 30 divided by 30 will be minus 1. So this will be 2a plus 29d equals to minus 1. Now to find the value of a and d, we'll solve the two equations simultaneously. So the first equation is a plus 12d equals to 12. And the second equation is 2a plus 29d equals to minus 1. Now we can substitute these values in our calculators to find the values of a and d directly as well. Or if we don't have that function in our calculators, we can solve it using the substitution or the elimination method. So for elimination, we'll make the a's equal with the opposite sign. So we'll multiply this equation by minus 2 and multiply this equation by 1. So the first equation will become 2 minus 2a plus 20 minus 24d is equals to minus 24. And the second equation will remain as it is. So this will be 2a plus 29d is equals to minus 1. So minus 2a and 2a will cancel. Minus 24 plus 29 is a plus 5d. And minus 24 minus 1 is minus 25. So d will be is equals to minus 25 upon 5, which is minus 5. Once we have the value of d, we can use this to find the value of a. So a will be, we can use the first equation, a plus 12d. So this will be 12 into minus 5 is equals to 12. This will be a minus 60 equals to 12. So a will be 12 plus 60, which is equals to 72. Now, once we have the values of a and d, we had to find the sum of the first 50 terms. We can apply the values of a and d into the formula for sum. So sum for 50 terms will be is equals to 50 divided by 2 into 2a. So a is 72 plus n minus 1. So this will become 50 minus 1 into d, which is minus 5. Substituting this in the calculator, the sum of the first 50 terms will be is equals to minus 2525. In question 3, the coefficient of x power 4 in the expansion of 2x square plus k square upon x power 5 is a. The coefficient of x square in the expansion of 2kx minus 1 to the power 4 is b. We have to find a and b in terms of the constant k. Now we know that the expansion formula for a plus b to the power n is equals to a power n plus nc1 a to the power n minus 1 b power 1 plus nc2 a to the power n minus 2 b to the power 2 and so on. Now for the coefficient of x square, we can try and guess which term to use, nc1, nc2, nc3, or we can use a different method to figure out which of these terms to use. So the method is that we write the expression as ncr a power n minus r b to the power r. We are trying to find the value of r. So as we are trying to find the value of r for which the coefficient for which x is power 4, so we'll just use the variable in place of a and b. So as a is x squared, so we'll write it as a x squared to the power n minus r. So as n is 5, so we'll write it as 5 minus r multiplied by b. So in b, x will be x to the power minus 1. As if you bring this x in the numerator, this will become minus 1 and b to the power r. And this is equals to x to the power 4. Simplifying this, we'll get x into x to the power 10 minus 2r multiplied by x to the power minus r is equals to x to the power 4. Now, as when we are multiplying the powers add, so we'll write the powers as 10 minus 2r plus minus r. So this will become minus r equals to 4. So minus 3r. So 10 minus 3r will be equals to 4, or 3r will be equals to 6, and r will be equals to 2. Now applying this to the formula, so as n is 5, this will become 5c2. A is 2x squared, so 2x squared to the power 2. And k, so this a to the power, it's n minus r. So this will become 5 minus 2. And b to the power, so b is k squared upon x to the power 2. 5c2 is 10, so this will become 10 into 2 cube is 8. So this will be 8x to the power 6. This will be k to the power 4 upon x squared. Now we can see that x power 6 and x power 2 will cancel to make x4. So the coefficient of x4 will be 10 times 8, which is 80 into k to the power 4. So as the coefficient of x4 is a, so we can say that a will be is equals to 80 k to the power 4. Now in the next expression, which is 2kx minus 1, so we'll write 2kx minus 1 to the power. So the power is 4 over here. The coefficient of x square is b. So for this, we can say now that if we take nc2, we'll get the power x squared. So we'll write it as 4c2 into 2kx to the power 4 minus 2 into minus 1 to the power 2. 4c2 is 6. 2 square will become 4 into k squared into x squared, and minus 1 whole squared is 1. So the coefficient of x squared will be 24k squared. Now as the coefficient of x squared was b, so the value of b will be is equals to 24k squared. Now in part B, it is saying that given that a plus b is equals to 216, we have to find the possible values of k. Now we'll use the values of a and b in terms of k. So a was 80k to the power 4. So we'll write 80k4 plus b was 24k squared. So in place of b, we'll write 24k squared is equals to 216. Now to solve this equation, first we try to bring it into a quadratic form using a substitution. So if we assume that x is equals to k squared, then x squared will be is equals to k to the power 4. Now substituting this, we'll get 80x squared plus 24x minus 216 equals to 0. And we can substitute this in the calculator to find the values of x, or we can just in question 4, we have to prove the identity sine cube upon sine minus 1 minus sine square upon 1 plus sine as minus tan square into 1 plus sine square. So we'll start this by first taking the LCM on the left hand side. So the LCM will be sine minus 1 and 1 plus sine. I'll be using S and T and C in place of sine, cos, and tan. So taking the LCM, this sine cube will multiply it by 1 plus sine, and this will be minus sine squared will multiply by sine minus 1. Expanding the bracket, we'll get sine cube plus sine to the power 4 minus sine squared plus, so this will become minus sine cube, and this will become a plus sine squared upon sine minus 1, and we can write this as sine plus 1. So sine cube and minus sine cube will cancel. In the numerator, now we have sine 4 plus sine squared. So we have sine 4 plus sine squared upon sine minus 1 sine plus 1. Now we can apply the basic identity from algebra, that is x minus y into x plus y is equals to x squared minus y squared. So we can write the denominator as sine squared minus 1. Taking sine squared common in the numerator, this will become sine squared plus 1 divided by sine squared minus 1. Now the identity that we had to prove was minus tan squared into 1 plus sine squared. So we already have sine squared plus 1 in the numerator. To get tan squared, this is sine squared. So in the denominator, we need a cos squared. Now we know that sine squared plus cos squared equals to 1, or cos squared is equals to 1 minus sine squared. But in the denominator, we have sine squared minus 1. To convert it to 1 minus sine squared, we'll have to multiply this by minus 1. So if you multiply this by minus 1, this will also multiply by minus 1. So this will become minus sine squared in the numerator plus 1, and this will become 1 minus sine squared. Now we can write this as minus sine squared upon cos squared into sine squared plus 1. So sine squared upon cos squared, now we can write it as minus tan squared theta bracket of sine squared theta plus 1, which was the identity that we had to prove. In part B, now it is asking us to solve the equation sine cube upon sine minus 1 minus sine square upon 1 plus sine equals to tan square into 1 minus sine squared. Now, the identity that we proved was minus tan squared into sine squared plus 1. So, in place of this, we can write minus tan squared into sine squared plus 1 is equals to tan squared into 1 minus sine squared. So now opening up the brackets, we'll get minus tan squared into sine squared minus tan squared is equals to tan squared minus tan squared sine squared. Bringing the tan square on the negative tan square on the right hand side, this will become tan squared plus tan squared, and taking the minus tan squared sine squared on the left hand side, this will become plus tan squared sine squared. So minus tan squared plus tan squared sine squared will become a 0. So this will be 0 is equals to 2 tan squared, or we can say that tan squared theta will be equals to 0, as 0 divided by 2 will be a 0. And if we take the square root of 0, that will also be a 0. So tan theta will be equals to 0. Taking tan inverse of 0, one of the values of theta will be equals to 0. And the second value will be pi. Now to understand this, we know that tan is positive in the first and the third quadrant. So if we make an angle of 0 in the first quadrant, this angle will be 0. And if we make an angle of 0 in the third quadrant over here, so this angle will be equals to pi. So the two values of theta will be 0 and pi. In question 5, the diagram shows a sector ABC of circle with center A and radius R. The line BD is perpendicular to AC and angle CAB is theta. In part A, it's given that theta is 1 upon 6 pi. We have to find the exact area of BCD in terms of R. Now to find the area of BCD, first we'll find the area of the sector and then subtract the area of the triangle ABD. So we'll write this as area of BCD will be is equals to area of sector ABC minus the area of triangle ABD. Now, finding the area of the sector, we know that the formula for area of sector is 1 upon 2 r squared theta. So this is 1 upon 2 r squared theta. We have to give our answer in terms of r. So this will be 1 upon 2 into r squared into theta, which is pi upon 6. We can simplify this to write it as pi r squared upon 12. Now to find the area of the triangle, we need the height and the base. So let's say we take BD as the height. This is opposite to the angle, so we'll write it this as opposite. So, and AB is the hypotenuse. So finding the length of BD, first, in the first step, we'll use sine theta. So in place of theta, we'll write pi upon 6 is equals to opposite, which is BD upon R. So BD will be is equals to sine of pi upon 6, which is 1 upon 2 multiplied by R. And then finding the length of AD. So as AD is adjacent to the angle, this will become cos of pi upon 6 is equals to AD upon R. Cos of pi upon 3 is root 3 upon 2 multiplied. So this will multiply by R. Now, once we have the length of AD and BD, will you apply the area of a triangle, which is half base into height. So area of triangle will be equals to 1 upon 2 into 1 upon 2R into root 3 upon 2R. Simplifying this will become root 3R upon 8. Finally, finding the area of BCD in terms of R. So area of BCD will be the area of sector, which is pi r squared upon 12 minus root 3R upon 8. And we can leave our answer in this form. In part B, it's given that the length of BD is root 3 upon 2R. We have to find the exact perimeter of BCD in terms of R. Now, the perimeter of BCD will consist of the length DC, the length BD, and the arc length of BC. Now, first, to find the length of DC, we know that this total length A to C is R, as this is also the radius. To find the length of AD, we already have the length of BD, which is root 3 upon 2R. So we can apply Pythagoras theorem. So hypotenuse over here is AB, which is R squared, is equals to root 3 upon 2r whole squared plus AD whole squared. Making AD the subject, we'll get AD square is equals to r squared minus, so root 3 squared is 3 upon 2 squared is 4 into r squared. Simplifying this, taking the LCM, this will become 4r squared minus 3r squared upon 4, which is equals to r squared upon 4. So AD will be is equals to the square root of r squared upon 4, which is equals to r upon 2. Now we have the length of AD and the total length was r, so DC will be r minus r upon 2, which is equals to r upon 2. So we have the length of DC as well, which is r upon 2. Now to find the arc length BC, we need the angle theta. To find theta, we can use sine, cos, or tan, as we have all the three lengths in the triangle, and it is a right angle triangle. So using sine theta is equals to opposite over hypotenuse. So sine theta will be opposite is root 3 upon 2r divided by the hypotenuse, which is r. R and R will cancel. So theta will be equals to sine inverse of root 3 upon 2. And theta will be is equals to pi upon 3. Now applying it to the arc length formula, S is equals to r theta. So r will multiply by pi upon 3. Finally, we can write the perimeter as the sum of the three sides. So the arc length is pi r upon 3 plus the length of BD was root 3 upon 2r plus the length of DC was r upon 2. And we can leave our answer in this form for the perimeter of BCD. In question 6, the function f is defined as f of x equals to x square minus 4 upon x square plus 4 for x greater than 2. We have to find an expression for f inverse. To find f inverse, we first write y in place of f of x. In the next step, we'll exchange the values of x with y and y with x. So this will be written as x equals to y squared upon 4 upon y squared plus 4. Now we have to make y the subject. So we'll cross multiply. This will become xy squared plus 4x is equals to y squared minus 4. Taking 4 on the other side, we'll get 4x plus 4 is equals to y squared minus xy squared. Now taking y squared common on the left hand side, we'll get 1 minus x is equals to 4x plus 4. And then y squared will be is equals to 4x plus 4 upon 1 minus x. To make y the subject, we'll take the square root on both the sides. So y will be is equals to 4x plus 4 upon 1 minus x. We can finally write this as f inverse of x is equals to square root of 4x plus 4 upon 1 minus x. In part B, it is saying that show that 1 minus 8 upon x square plus 4 can be expressed as x square minus 4 upon x square plus 4, and then state the range of f. Now to show this, we'll first take the LCM. So as the LCM is x square plus 4, we'll multiply 1 by x square plus 4. So this will be x square plus 4 minus 8. Simplifying this, we'll get x square minus 4 upon x squared plus 4. Now to state the range of f, the function f of x can also be written as 1 minus 8 upon x squared plus 4, and the value of x was greater than 2. Now to find the range, first let's take the value x equals to 2 over here. So what we'll see is that if I take x as 2, 1 minus 8 upon this will become 2 squared plus 4. So this will be 1 minus 8 upon 8, which is 1 minus 1, which is equals to 0. Now at f of 2, the value of f of x was equals to 0. Now, if we keep on increasing the value of x as it is greater than 2, what we'll see is that 8 upon any of the value will always be less than 1. So let's say if we take 3, 4, or 5 in place of x, 8 divided by 3 square plus 4, 8 upon 13 will always be less than 1. So the answer 1 minus any value less than 1 will always be less than 1. So we'll say that f of x will be greater than 0, as it cannot be 0 as x is greater than 2 and it's not equal to 2. And it will always be less than 1. So this will be the range of f. In part C, it is saying explain why the composite function ff cannot be formed. So if you look at the function f of x was equals to x square minus 4 upon x square plus 4, x was greater than 2 and the range of f of x was less than 1 and greater than 0. Now, when we talk about f of f, it means that in place of x, we have to replace the function f of x. So it means that this will take the values of x. However, we can see that x has to be greater than 2, but the range of f of x is only from 0 till 1. So we can say that the range of f of x does not lie in the domain of x, does not lie in the domain of f. So this composite function cannot be formed. So we can write a final answer as that the range does not have the domain or does not include the domain of f for any of the values of x. Have the domain for any values of x. Again, just to explain this, basically this means that if f of x is taking the x values, it has to be greater than 2, and f of x cannot be greater than 2 as f of x was less than 1 and greater than 0. So this means that we cannot find the function, the composite function f of f. In question 7, the diagram shows the curve with the equation y equals to 3x minus 2 power 1 upon 2 and the line y equals to half x plus 1. The curve and the line intersect at point A and B. In part A, we have to find the coordinates of A and B. Now, to find the coordinates, we'll solve the equation simultaneously. So the curve equation is y equals to 3x minus 2 to the power 1 upon 2. And the equation of the line is 1 upon 2x plus 1. So to get rid of 1 upon 2, we'll whole square both the sides. So whole squaring 3x minus 2 to the power 1 upon 2, this will become 3x minus 2. And this will become 1 upon 2x plus 1 whole squared. So expanding 1 upon 2x plus 1 whole squared, this will become 1 upon 4x squared plus 2 into 1 upon 2x into 1 plus 1 squared. We have applied the formula a squared plus 2ab plus b squared. Simplifying this, this will become 1 upon 4x squared plus x plus 1 is equals to 3x minus 2. So taking the LCM, we'll get 3x minus 2 is equals to x squared plus 4x plus 4 upon 4. Cross multiplying, this will become 12x minus 8 is equals to x squared plus 4x plus 4. Bringing the 12x and 8 on the right hand side, this will become x squared plus 4x plus 8 plus, so this will become x squared plus 4x minus 12x as that was a plus 12x, so this will become a minus 12x and plus 4 plus 8, so this will become a plus 4 plus 8. So the final equation will be x squared 4x minus 12x is minus 8x plus 12 equals to 0. Factorizing this, we'll get x minus 6 and x minus 2 equals to 0. So the two values of x will be x equals to 6 and x equals to 2. Now, once we have the x values, we can substitute this into the equation of the line or the curve to get the y values. So using the equation of the line, which is easier, so we'll use 1 upon 2x plus 1. Substituting 6 over here, we'll get 1 upon 2 into 6 plus 1. So 6 upon 2 is 3 plus 1, which is equals to 4. So when x is 6, the value of y is 4. So the coordinate will be 6, comma 4. And when x is equals to 2, so this will be 1 upon 2 into 2 plus 1. So 2 and 2 cancels and the value of y is 2. So when the value of x is 2, the y value is also 2. In part B, it is saying to find the area of the region enclosed by the curve and the line. So to find the area of the region enclosed by the curve and the line, which is the area in between, we'll find the area under the curve and then we'll find the area under the line and subtract the two areas to find the area between enclosed by the curve and the line. We already know that the limits are 6 and 2. So to find the area, the limits will be 6 and 2. The equation of the line is 3x minus 2 to the power 1 upon 2. And then we'll subtract this from the area under the line, which is 1 upon 2x plus 1. And the limits in this case will also be 6 and 2. Now integrating 3x minus 2, this will be 3x minus 2 to the power half. This will become 3x minus 2 to the power 3 upon 2 divided by 3 upon 2, the new power, and the derivative of 3x minus 2 will be 3. So the 2 will go into the numerator, and this will become 2 upon 9 into 3x minus 2 to the power 3 upon 2. And the limits will be 6 and 2. Now integrating the equation of the line, this will be 1 up. So when we integrate, we'll remove the integration sign. This will become, we'll increase the power of x by 1. So this will become x squared, and divided by the new power, which will become 4. And this will, with the integration of 1, will make it x. And the limits will be 6 and 2. So we have integrated the equation of the curve and the line. And now we'll apply the limit 6 and 2 for both the equations and then subtract the answers. So now substituting 6 in place of x, we'll get 3 into 6, which is 18, minus 2 to the power 3 upon 2, minus the lower limit, which is 2. So this will become 2 upon 9 into 3 into 2 minus 2 to the power 3 upon 2. So 18 minus 2 is 16. 16 square root of 16 is 4, and 4 cube is 64. 64 times 2 will make it 128 upon 9. We can directly substitute this value in the calculator as well. And then 6 minus 4 is 2. Square root of 6 minus 2 is 4. So the square root of 4 is 2. And 2 cube is 8. So 8 times 2 will become 16 upon 9. So we'll subtract 16 upon 9, which will be 112 upon 9, which is the area under the curve. And now applying the limits to the line. So this will be equals to x squared upon 4 plus x. So in place of x, we'll write 6 squared upon 4 plus 6 minus the lower limit, which is 2 squared upon 4 plus 2. So 6 squared upon 4 is 36 upon 4, which is 9. 9 plus 6 is 15, minus 2 squared is 4 upon 4, which is 1 plus 2, that will be 3. So 15 minus 3 will be equals to 12. Finally, subtracting the two areas, we'll get 112 upon 9 minus 12. Taking the LCM, this will be 112 minus 912 times is 108 upon 9. So the final answer will be 4 upon 9 for the region enclosed by the curve and the line. In question 8, the curve y equals to sine of x is transformed to the curve y equals to sine half x minus 30. We have to describe fully a sequence of transformations that have been combined and making clear the order in which the transformation is applied. Now, if y equals to sine x has been converted to y equals to 4 sine of 1 upon 2x minus 30. So the transformations that have been applied, this 4 represents a stretch in the y direction, and the scale factor in this case will be equals to 4. This half x represents a stretch in the x direction. So we'll write there will be a stretch in x direction, and the scale factor will be 2 as it is 1 upon 2. So the scale factor over here will be equals to 2. And this 30 degrees basically represents a translation or a movement in the x or the horizontal unit, and the translation vector will be 30 and 0. Now, to put this in order, we can put the stretch in any order. However, when there is a movement in the x direction, we apply the arithmetic operation, the opposite of arithmetic operation. So in arithmetics, we first multiply and then we add or subtract. However, when we are talking about movements in x direction, first we'll always apply the addition or subtraction transformation, and then the multiple or division. So we can put the translation as a first transformations. We can write it as there will be a translation first. So this will be translation of 30 and 0. So this is basically addition or subtraction in the x direction. And then the stretch, which is a multiplication in the x direction. So the stretch will be of scale factor 2. So we'll write stretch in the x direction, and scale factor will be equals to 2. And we can finally write there will be a stretch in the y direction and the scale factor will be 4. Now, this stretch in the y direction could have been in any place, or it could have been in 1, 2, or 3. However, we'll always put the translation in x before the stretch in x direction. In part B, we have to find the exact solution of the equation 4 sine half x minus 30 equals to 2 root 2. So in the first step, we will divide 4 on the other side. This will become half x minus 30 is equals to 2 root 2 divided by 4. So 2 and 4 will cancel out. We'll get square root 2 upon 2. Now taking sine inverse of 2 root 2, we'll get the basic angle. So sine inverse of 2 root 2, if we substitute this in the calculator, the basic angle will be equals to 45. Now, as it is a square root, we can assume that we'll take sine in the positive and the negative quadrants. So this angle will be 45 up here. We'll make a 45 up here. We can make a 45 up here and here as well. Now, finding the value of x, we'll put half x minus 30 is equals to, the first angle will be 45. So we'll put it equals to 45. Solving this, we'll get half x is equals to 45 plus 30, which is 75. So x will be equals to 150. Then using the other angle, which will be 180 minus 45. So half x minus 30 will be is equals to 180 minus 45, which is 135. Adding 30 on the other side, we'll get half x is equals to 165. And then multiplying it by 2, we'll get 330 degrees. Now, if we solve for the remaining angles, so the another angle we can use will be 180 plus 45, which is 225. But when we add 30 and multiply it by 2, it will go above 360, as x has to be in between 0 and 360. So the two values of x will be 150 degrees and 330 degrees. In question 9, the equation of a circle is x squared plus y squared plus 6x minus 2y minus 26 equals to 0. We have to first find the coordinates of the circle, center of the circle and the radius, and then find the coordinates of the lowest point on the circle. Now, the general equation for a circle is given by x minus a whole squared plus y minus b whole squared equals to r squared. So to find the center and the radius, a comma b is the coordinates for the center and r is the radius. So we'll expand this and compare it with the equation to find the value of a, b, and r. Now expanding this, we'll get x squared minus 2ax plus a squared plus y squared minus 2by plus b squared is equals to r squared. Rearranging this to write it as the equation above, we'll write it as x squared plus y squared minus 2ax minus 2by plus a squared plus b squared, and we'll bring the r squared on the left hand side and put it equals to 0. Now the coefficient of x in this term is minus 2a, and in the original equation that was plus 6. So a will be equals to 6 divided by minus 2, which is minus 3. And the coefficient of y over here is minus 2b. So this will be equals to minus 2b will be equals to minus 2 over here. So the value of b will be positive 1. Now to find the value of r, this will be a squared plus b squared minus r squared, and that will be equal to the constant, which is a minus 26. So we have the value of a and the value of b. So this will be minus 3 squared plus 1 squared minus r squared equals to minus 26. To find r, we'll make it positive and take it on the right hand side. So this will be 9 plus 1, and this will become a plus 26 equals to r squared. So r squared is 36, and the value of r will be equals to 6. So now we have the coordinates of the center. So that is minus 3 comma 1, and the radius is equals to 6. Now we also have to find the coordinates of the lowest point on the circle. Now to understand this, let's try and make a circle first over here. And the center is minus 3 comma 1. So let's say this will be the center of the circle. Now, as the radius is 6, it means it will be 6 units below this. The lowest point will be 6 units below this point. So if this value was 1, it will decrease by 6, which will become a minus 5, and the x value will remain the same. So the lowest point on the circle will have a coordinate, -3 and -5. In part B, we have to find the set of values of the constant k for which the line with the equation y equals to kx minus 5 intersects the circle at two distinct points. So we'll be solving the equation simultaneously, the equation of the circle and the equation of this line. And as we have an unknown constant, we will apply the discriminant b squared minus 4ac. And as the intersection is at two distinct points, we'll put it equals to 0. So first writing the equation of the circle, the center point was -3 and 1. So we'll write it as x plus 3 whole squared plus y minus 1 whole squared, and that will be equals to 36. Now we'll replace y over here with kx minus 5. So we'll first write it as x plus 3 whole squared plus kx minus 5. So this will become kx minus 5 minus 1 whole squared equals to 36. We'll simplify the bracket over in kx minus 5 minus 1, which will make it kx minus 6 whole squared equals to 36. Now expanding both of the brackets, we'll get x squared plus 6x plus 9. And over here, it will become k square x squared minus 2ab. So that will be minus 12kx plus 36 is equals to 36. So when we bring this 36 on this side, it will cancel out. So 36 will cancel out. We can now rearrange our equation and put the x squared terms together. So this will be x squared plus k square x squared plus 6x, and the other x term was minus 12kx plus 9 equals to 0. So taking x squared common, this will become 1 plus k squared, and taking x common from over here, this will become 6 minus 12k, and this is a plus 9. So the value of a is 1 plus k squared, the coefficient of x squared. The value of b, which is the coefficient of x, is 6 minus 12k, and c will be equals to 9. Now, putting it in the formula b squared minus 4ac greater than 0, we will get 6 minus 12k whole squared minus 4 times a, which is 1 plus k squared times 9, and it is greater than 0. Expanding 6 minus 12k whole squared, this will become a 36 minus 2ab. So 2 times 6 is 12, and 12 times 12 is 144. So this will be 144k plus 12k squared will be plus 144k squared. And then minus 4 times 1 times 9 will be a minus 36. And minus 4 times k squared into 9 will become a minus 36k squared greater than 0. Now simplifying this, 36 and 36 will cancel out. 144k squared minus 36k squared is 108k squared minus 144k, and we'll put it equals to greater than 0. So taking, let's say we take 4k common from over here, this will become, so 108 divided by 4 is 27k, and 144 divided by 4 will become 36 greater than 0. So one of the values of k will be 4k equals to 0. So k will be, one of the values of k is 0, and 27k minus 36. So if we find the value of k in this case, that will be equals to 36 upon 27, which is 4 upon 3. Now it is important to know how to give the correct inequality sign. So the two values of k that we got are 4 upon 3 and 0. As the value is greater than 0, it means we are looking for values of x that for which the whole curve will be greater than 0. We can see that if we move backwards from the point 0, x equals to 0, the value will be greater than 0. So we'll give x is less than 0, and moving forward from 4 upon 3, the value will be greater than 0. So x has to be greater than 4 upon 3 for b squared minus 4ac to be greater than 0. In question 10, the equation of a curve is such that the double derivative d square y upon dx square is 6x square minus 4x cube. The curve has a stationary point at -1, 9 upon 2. In the first part, we have to determine the nature of the stationary point at -1, 9 upon 2. So for the nature, we'll substitute the value of x into the double derivative. And if it is greater than 0, it will be a minimum point, and if it is less than 0, it will be a maximum point. So substituting x equals to -1, we will get 6 into -1 whole squared into -1 whole cube. So this will become a +1, and -4 upon -1 will make it a 6 plus 4. As this is greater than 0, this means it will be a minimum point. Now in part B, we have to find the equation of the curve. To do this, first we will integrate it to get the expression for dy dx, and then we'll integrate it again to get the expression in terms of y. So now integrating d square y upon d square x. So this is 6x square minus 4 upon x cube. Integrating this, we'll get dy by dx, and this will become 6x cube upon 3. And to integrate 4 upon x cube, first of all, we'll write the x cube in the numerator. So we'll write it as -4x to the power -3. So integrating -4x to the power -3, the power will increase by 1 and it will become a -2, and we'll divide by -2 and we'll add a plus c. We can simplify this to write it as 2x cube plus, so this will become a minus will become a plus. 4 divided by 2 is 2, so this will be 2 upon x squared plus c is equals to dy upon dx. Now, as the stationary point, the coordinate was -1, 9 upon 2, and at the stationary point, the dy dx is 0, so we can write this as 0 over here and put the value of x is -1 whole cube plus 2 upon -1 whole squared plus c. So 0 will be equals to -2 plus 2 upon -1 whole squared will be positive 1. So this will be 2 plus c. So -2 plus 2 is 0. So in this case, c will be equals to 0. Now, once we have the value of c as 0, now we can integrate this expression again and get rid of the value of c. So first we'll write that dy dx will be equals to 2x cube plus 2x to the power -2. Now, integrating both the sides, we'll get y is equals to, so we'll increase the power by 1. This will become 2x4 upon 4. Increasing the power by 1, this will become a -2 plus 1 will become a -1, and we'll divide by -1 and we'll add a plus c. So y will be equals to 1 upon 2x to the power 4 minus 2x to the power -1 plus c. Now, to find the value of c, we'll substitute the points that were given, and the point was -1, 9 upon 2. So in place of y, we'll write 9 upon 2 is equals to -1 upon 2 into -1 to the power 4 minus, so we can write this x power -1 as 2 upon x and substitute -1 over here plus c. Solving this, we'll get 9 upon 2 is equals to 1 upon 2. So -1 to the power 4 will become a +1, and this will become a +2 plus c. So we'll write it as 9 upon 2 minus 1 upon 2 minus 2 is equals to c. 9 upon 2 minus 1 upon 2 is 8 upon 2, which is 4, and 4 minus 2 will be equals to c, which is equals to 2. So once we have the value of c as 2, the final equation will be y equals to 1 upon 2 x to the power 4 minus 2 upon x plus 2. In part C, it is asking us to show that the curve has no other stationary points. So to show that, first of all, we'll look at the expression for dy dx, which was 2x cubed plus 2 upon x squared. So we had dy dx is equals to 2x cubed plus 2 upon x squared. Now, for a curve to have a stationary point, it means the dy dx will be equals to 0. So we'll put it equals to 0 and try and find the values of x. So taking the LCM, we'll get 2x to the power 5 plus 2 upon x squared equals to 0. Cross multiplying, this will become 2x to the power 5 is equals to -2. So we have taken this 2 on the other side, and so 2x power 5 will be equals to -2, or x powered 5 will be equals to -1. Now, if it even take the root 5 of -1, the value of x will still be a -1, which means that there is no other stationary point on the curve. In part D, a point is moving along the curve and the y-coordinate of A is increasing at a rate of 5 units per second. So which means that the y-coordinate is increasing means that the dy dt will be is equals to 5. We have to find the rate of increase of the x-coordinate. So we do not know this value dx by dt, which is an unknown, and the point is x equals to 1. So the formula relating dy dt and dx dt is dy dt is equals to dy dx multiplied by dx by dt. So we have the value of dy dt, which is 5. Now to find the value of dy dx, we know that the expression for dy dx was, in the previous part, it was 2x cubed plus 2 upon x squared. So this will be 2x cubed plus 2 upon x squared. Substituting the value x equals to 1, we'll get 2 into 1 whole cube plus 2 upon 1 squared. So this will be equals to 4. So we'll write it as 5 is equals to 4 into dx by dt. So dx by dt will be is equals to 5 upon 4.